Hello, Dr. K. Today I'll show you my homework, chapter 2.1 to you. It's about Arduino. So you can see the title of this research is about Arduino DC motor control experiment. Uh, the content of this research is five parts. The first one is experiment objectives and significance. The second one is hardware component and connection. Then the code architecture and logic. Then implementation flowchart. The last one is key technological insights. Okay, so let's see the first part, experiment objective. This experiment established a foundationally embedded system component through particle Arduino model control implementation. Addressed real-world changes include mechanical bounce, state management, and bidirectional motor control. Master digital I/O improvement, digital input detection for push button, state reading using input pull-up mode, alongside digital output control for L 298 single pins, understand pin mode, digital read and digital write function for the microcontroller interfacing. Uh, the foundational learning value. It has I take it into four pieces. So you can see input detection, output control, state management, and anti-interference. The software debouncing, preventing false triggering in consumer electronics, ensure reliable user input in industrial control, and elimination bounce induce errors in chemical system, and improving product reliable and user experience. Uh, and particle application value, single button multi-state control logic directly migrate to device application. The driver knowledge value, these control principles, electronic control logic is level combination control current directly, and power management, isolating motor power from logic supply, and the current application, low power single stripe high power loads, and bidirectional control, reversing priority for motor direction. Okay, the hardware component. Uh, we need Arduino board and Traco push button and L uh, 220 298 and driver and DC motor and power supply. The last one is writing and breadboard. You can see the motor driving architecture. So the how to connect this hardware? You can see we put push button connect to the Arduino pin 2, and the int 1 connect to the pin 9, and the int 2 to the pin 10. The out 1 and 2 connect to the DC motor, and the power to the jumper to the 5 volt. So uh, let me explain my code. You can see the global definition and the variable declaration. You can see. So the setup function of this C++, you can see the function purpose. Setup is a standard Arduino function that execute once after power down and reset. It configure it configures hardware, initialize state, and establish communication before loop begins. Uh, you can see the analyze I turn into three pieces. You can see it's step by step. The pin configuration, pin mode enable internal pull up and the button rate high when unpressed, low when pressed. Element external resistor. And the number two is motor state initialize. Stop motor ensures motor is stationary at startup. Prevention unexpected behavior. The third one is serial communication. Serial dot begin enable USB communication, and 9600 baud is standard speed. And let's see the main loop function. It's about debounce logic. You can see the digital read gets current pin state, and the detect change compare with last button state. If it's different, reset timer. So you can also see the weight and the target. You can see the uh, main motor control function, hybrid logic. The stop function into one is low, into two is low. No vantage or cause motor. It calls to a stop. And if int is high, int two is low, current flow from out one to out two. Motor rotator rotates clockwise, and the reverse function is if int one is low, int two is high, current flows from out two to out one. Motor rotate is counter to clockwise. The chart on the left is com component excursion. You can see. So the textual exclusion process, the one is power down initialization. The second one is hardware configuration and continuous bottle polling and state Martian exclusion. Okay, the key technological insights. The blocking with non-blocking, and the mechanical bounce physics, the algorithm advantage, algorithm walk through. The last one is summary and the key takeaways. The core functionality. This experiment demonstrate one button calculate motor control, and the hardware essentials. Mm, Common ground is critical for single integrity, and the power supply must match uh, motor rating. These skills directly enable robotics, automation, and IoT application. More monitoring, debouncing, state marching, and motor control is essential for any embedded system developer. Okay, so let's see the achievements.
听到电机转声音了。
Okay, that's all. Thank you.